Welcome back to P1. Today we're looking at quadratic inequalities. Now, for the most part, this is very similar to solving quadratic equations. You do that will give you your critical values, and then a simple sketch then will help you work it out in terms of an inequality. Let's have a look what I mean. So say I have this inequality here. X squared plus 5x is less than 6. What I want to do is I want to first turn it into an equals and make it equal 0. So x squared plus 5x equals 6. X squared plus 5x minus 6 equals 0. Once I make it equal to 0, then I can solve this equation. Firstly, check if you can factorize, and if not, you might need to use the formula, but a lot of the ones we're going to do today will be factorizing. So looking at this one, it's got to be a 6 and a negative 1. That'll give me my negative 6, and that'll also give me my positive 5x. So my critical values are x equals minus 6 and x equals positive 1. Now what I do is I want to think about my inequality. So my inequality is x squared plus 5x minus 6 is less than 0. Okay, obviously matching very much up with how we just solved it for our critical values. And what I want to do is I want to do a very quick sketch. So I know it's going to cross at 1 and minus 6, and it's a positive x squared, so it's going to look like this. Now once I've done my graph, I need to go back to my inequality. This says that the graph will be, or the curve will be, less than 0. So less than 0 means below my x-axis. So that means it's this section of curve here. So if I highlight that in red, it's this section of curve. That clearly means that I want to the right of the minus 6 and to the left of the positive 1. That's what's going to give me a value below the axes. So my inequality is smaller than 1 but greater than minus 6. Now it's just one region, that's all it's shaded as you can see there, so I can write it as one inequality. So x greater than minus 6 but less than 1. Now if you need to write this in terms of set notation, then you should be writing it as follows. And don't forget to put this into the brackets. Nice and easy. Now, the second example, find the set of values of x for which x squared is greater than 12 minus x. So let's again make this equal to 0. X squared plus x minus 12 will be greater than 0. And I want to find my critical values, so x squared plus x minus 12 equals 0. So I solve it like an equation first for my critical values. So this is going to be a plus 4 and a minus 3. So x equals negative 4, x equals 3. These are my critical values. And it's useful to call them that, as he's showing that, you do know the difference between an equation and an inequality, but you do need to know what these critical values are. So then we always do a sketch, and you always need to do a sketch. Okay, if you don't do a sketch or some way of showing it, just writing down the inequalities based on these critical values might not get you the marks. So make sure you do your sketch. Minus 4 and plus 3, it's a positive x squared, so it looks like this. We want it when it is greater than 0. So greater than 0 comes when my line's above the x-axis. So here and here. That means I want everything to the right of 3 and everything to the left of 0. And what you can also see is that I've got two clearly different regions this time. So I want to do them separately. So I want to write that x is less than -4 or x is greater than 3. I don't want to put these together as they are not one region, they are two separate regions. So this is how you should be writing your answer. Obviously, if the question had a greater than or equal to, then that would be reflected in my answer as well. Now, as set notation, this could be written as this. Now, when you do it, U is union, it's like or. So very much like how we previously did set notation. It works the same here. Find the set of values for which x squared plus 2x minus 8 is less than 0 and 3x plus 8 is greater than 5. So what I need to do here is essentially work out these two separately first. So x squared plus 2x minus 8 equals 0. Try to factorize first. So we're looking at a 2 times 4 plus 4 and minus 2. So our critical values are x equals 2 and x equals -4. Let's then have a quick little look at our graph. So we're going to cross add -4 and 2. Again, positive. I've done all positive ones here. I should have done at least one negative. Anyway, and we want less than 0, so we want it to the right of -4 and to the left of 2. So x is less than 2 but greater than -4. Let's have a look at the other one. So my other one, I'm going to do this one in red so you can see the two separately. So I want to take away 8 first of all. 3x then is greater than -3. Divided by 3, x is greater than -1. So these are my two sets of inequalities. Now I want to compare them together and find the set of values that works for both. So let's just set these out nice and kind of make them obvious. There we are. So I've got one set which is between -4 and 2, like so, and I've got the other one which is greater than -1. So we've got our other one then which is greater than -1, and that obviously goes on forever. So the part where they both work is this part here, isn't it? So it's between -1 and 2. So that's my answer, -1 and 2. So x is greater than -1 but less than 2. And that's hopefully, you don't have to show it visually like I did there in green. You can just work that out in your head, but it's nice to show it visually sometimes. Final example here, and this one you do have to be careful of. So before we actually get into this one, what I want to think about is what happens to an inequality if you multiply by or divide by a positive or negative number. So, dividing by a positive or negative number affects the inequality sign. Let's have a little look at a simple example that should show you and demonstrate this. So if I've got this example, if I solve this properly, what I would normally do is take away 5x from both sides. That leaves me an inequality like this. 12 is greater than 2x. I would then divide by 2. So you can see quite clearly here that x is less than 6. Now, if I take that same example and I take 7x from both sides, you can see I'm left with minus 2x plus 12 is greater than 0. Take away 12 from both sides, minus 2x is greater than negative 12. And if I just divide it by 2x, x is greater than positive 6. So x is greater than 6. Now this answer is not the same as this answer here. This is x is less than 6, this is x is greater than 6, but I started with the same thing. So there must be a mistake there. Okay, I know I can add or subtract and keep this balanced, so the mistake comes from when I divided by negative 2. So when I divide by this negative 2, what actually happens is the sign switches. And it's something I've got to be aware of and be careful of. Now let's have a look at our problem. We've got 8 over x greater than or equal to 4. If I simply multiply by x, I would end up with this. However, my issue comes is that x is an unknown value and I don't know if it's a positive number or a negative number. If it's a positive number, what I've done is perfectly fine. But if it's a negative number, what I've done is actually messed up the whole sum and it's actually not correct. So what we have to do is we have to kind of think of a way around this. And the way we get around this is by multiplying by something that we know is definitely positive. So what I'm actually going to do is I'm going to multiply through by x squared, since x squared is always positive. So if I multiply the left side by x squared, I get 8x, and on the right side I get 4x squared. I can now take away 8x, and that leaves me with 4x squared minus 8x on my right. I'll then go ahead and factorize, so 4x would come out, leave me with x minus 2 inside the brackets. So now what I've actually got is I've got a couple of critical values. So my critical values here are 4x equals 0, therefore x equals 0. And x minus 2 equals 0, therefore x equals 2. So then thinking about this as positive x squared between 0 and 2. And we want when this is less than 0, so we want this bit. So my final answer here is that x is less than or equal to 2 or greater than or equal to 0. Okay, and this type of question is probably the question that most people will get wrong in the exam, because they'll forget that you need to multiply through by a positive number, and that means using a squared term, not just an unknown. Now I'm going to give you a few to try yourself, and as always I'll put the answers at the end of the video.